So just to go over exercise 10B question 59. You've been asked that if y equals 3x squared minus x, show that the left-hand side equals the right-hand side. So what I would do with this question is work with the left-hand side because it's more complicated. So let's work with the left-hand side. So if you've been given y, we need to find out what dy by dx is. So if y equals 3x squared minus x, dy by dx will be 6x minus 1. And then the second derivative will be given as 6. So now it's just a case of substituting into the left-hand side and tidying it up and hoping that it equals 6x. So let's make a start. So the first thing we need to do is write down y. So you've got 3x squared minus x. And we're multiplying that by the second derivative, which is 6. We're adding on dy by dx, so 6x minus 1. We're taking away 6y, and y in the question was 3x squared minus x, and then adding on 1. So let's tidy that up. So multiplying out the brackets, you're going to have 18x squared, take away 6x, plus 6x minus 1, minus 18x squared minus 6x plus 1. Sorry, that should be a plus 6x there. So tidying that up, 18x squared, take away 18x squared 0, minus 6 at 6 is 0, so you're just left with 6x, minus 1 at 1 is 0. So you've now shown that that's equivalent to the right hand side. So we're done with question 59. Question 62, you're told that the straight line cuts the curve y equals x squared minus 2x at 2 points. Find the gradient at these 2 points. So if you need to find the gradient at the 2 points where that curve cuts with that straight line, you're asking where do they meet? So where do they meet? In other words, find the intersection. And how do you find the intersection between a straight line and a curve? You put them equal to one another. So we have 4x take away 5 is equal to x squared minus 2x. You now just need to rearrange and solve it. So 0 equals x squared minus 6x at 5. Factorising, what multiplies to give you 5 and adds to give you minus 6, you're going to have minus 1 and minus 5. So x equals 1 and x equals 5. So where do those lines intersect one another at the coordinate x equals 1 and x equals 5? What would the y coordinate be? I am just substituting into 4x minus 5. So if x is 1, 4 times 1 is 4. Take away 5 is minus 1. And when x is 5, 4 5s are 20. Take away 5 is 15. So this is just telling me that the line and the curve intersect at those coordinates. Okay, right, what are we actually trying to do? We've been asked to find the gradient of y equals x squared minus 2x at these 2 points. In other words, differentiate it and find the gradient at x equals 1 and then find the gradient at x equals 5. So differentiating that, dy by dx, we have 2x minus 2. So at x equals 1, the gradient is 2 times 1 is 2, take away 2 is 0. So that's your first answer. And at x equals 5, the gradient will be 2 times 5 is 10, take away 2 is 8. So your two answers is the gradient is 0 and the gradient is 8 at the point where the line and the curve intersect. Okay, question 63. You're told the gradient of y equals x squared minus 4x at 6 at the point 3, 3 is the same as the gradient of y equals 8x minus 3x squared at the coordinate AB, and we need to find the values of AB. So we've been told that the gradients are the same at that particular point. So let's work out what the gradient is at the point x equals 3. So just to put that in words, find the gradient at x equals 3. So dy by dx will have 2x minus 4. So at x equals 3, the gradient is equal to 2 times 3 is 6, take away 4 is 2. So the gradient will also be 2 at the coordinate x equals a. So what we need to do now is differentiate the second equation. So dy by dx equals 8, take away 3 times 2 is 6, so 6x. So at the coordinate a, the gradient is also the same, so the gradient is 2. Okay, so solving that, we'll have 6x equals 6, so x equals 1. In other words, a equals 1. We need to find b, the y coordinate. Okay, so just substituting into the original. So you had y equals 8x minus, is that a 3x squared? So if x equals 1, you're going to have 8 take away 3, which is 5. In other words, b equals 5. So AB is 1, 5. And that's us done.